How sure are we about the Big Bang? Like, is there a cosmic dust equivalent of like something that might be causing us to think there was a Big Bang when there really wasn't?
So for every theory, there's always a counterpoint. There's always somebody who doesn't believe in the theory, who will make their career, based on the quest to disprove the prevailing theory, to show that they're all idiots and that only they know the truth. And
it's called Newton's third law.
I think it's Clarke's law. Clarke said, for every expert, there's an equal and opposite expert. And he's the namesake. He gave us the namesake of the podcast. So to answer your question, there are, I like to joke, there are members of the Flat Earth Society all over the globe, right? So there are people that believe it everywhere, right? There are people that don't believe the moon landing occurred. There are people that don't believe in evolution via natural selection and chromosomal heredity. All sorts of things. People have belief in their own theory, or they believe that the prevailing wisdom is a conspiracy. For what reason? At least for the moon landing, you could kind of see there's a conspiracy. I'm not justifying it, but NASA, is embarrassed because they said they could do it, and JFK, pushed the country to do it as a big source of national pride. We want to beat those nasty Soviets and Russians and whatever, and so they lied about it. But that's total nonsense. I mean, you could prove that it happened. Colleagues of mine here have studied not only the moon, but measured the position to the moon to better than a millimeter using lasers shot at the moon. From New Mexico, and they're reflecting off of the very exact reflectors that were left by the astronauts that they have pictures of themselves putting there. And it's known not only by the U.S., but by every country that does this type of metrology to measure things in the solar system and the universe. So it's a total joke. But at least you can see how people do it. The Big Bang opponents that deny, I call them Big Bang deniers, liar, liar, Big Bang denier. I do videos about these people. They're really buffoons. They, in some cases, have... They have ulterior motives that they are, in some cases, one guy is trying to build a very low energy neutron mediated fusion reactor in Pennsylvania somewhere. And he's always getting people to give donations. And the way that he does it, he makes a big case that the Big Bang never happened, and that all of cosmology is a sham and a scam. It never happened. But actually, in this very office, the previous occupant of this office was named Jeffrey Burbidge. And he was an amazing astronomer, cosmologist, and he never believed in the Big Bang. And he was here for a very long time. The guy who came up with the name Big Bang, Fred Hoyle, didn't believe in the Big Bang. They believed in what's called the steady state universe, that the universe always existed and always would exist, and it was changing slowly. And the way that it got the behavior where we saw galaxies moving away is that there were pieces of helium and hydrogen that were created every year in the universe and only need a tiny amount to cause the universe to expand. So they went to their graves thinking that the Big Bang never happened. They didn't have the kind of violent antipathy that these other people do for some reason, that are really obsessed and hate things like the James Webb Space Telescope and hate NASA and hate cosmologists like me. But they were pretty vehement. So the answer is because no theory is perfect. Even the theory, so if the flat earthers said the following, if they said the Earth is not a sphere, I would agree with them. The Earth is not a sphere. The Earth is what's called an oblate spheroid. It has a distortion because it was once molten and it's bulging at the equator, like some of us do as we get older, because it's rotating. So it has deviations in the spherical harmonics that are along the midplane of the Earth, and there are other deviations too. Plus Mount Everest and here in California we've got Death Valley. So there are variations. So it's not a perfect sphere. So that would be right, but they don't say that. They say the Earth is flat. So they make a concrete claim with high precision. They say the curvature of the Earth is 0.0000, and we know we can roll that out at infinite sigma, an infinite number of standard deviations. We can say that the Earth is spherical to within so many standard deviations, and we can say what the deviations are. We can account for those very accurately, but at the end of the day, we can never prove a scientific fact. Karl Popper said you can never prove something in science the way you can in math. You can prove 1 + 1 = 2, which is another thing people dispute online. I'm in a debate with this guy, Terrence Howard, about 1 × 1 = 2. He claims that. And, he's a brilliant, actor and everything else. But, I said, if they gave you one paycheck for, $1 million and then they gave you another paycheck for $1 million, would that not be $2 million, or would you expect
more? I would want to do business with him.
Right, exactly, right. So at the end of the day, there'll always be detractors, doubters, and so forth, but the onus is on them once you have enough preponderance of evidence to support a scientific claim. So we have really 3 or 4 different pieces of evidence that point to what we call the Big Bang. If you say the Big Bang is the origin of time, that's where we can start debating if that's true. But the Big Bang theory is really referring to the formation of the earliest elements, the lightest elements on the periodic table of the elements. I got a chart behind you over there, and the formation of the cosmic microwave background, the formation of the first stars, the first galaxies, first clusters of galaxies, and everything else that goes into them. And people always say, well, how can you guys talk about the Big Bang with such confidence if you don't know what 95% of the universe is made up of? We don't know what that's true. We don't know what dark energy is, and we don't know what dark matter is. We've never detected a particle of dark matter. We've never detected a quantum of dark energy. And lately, it's been as exciting as I can remember it's the second major paradigm shift that may be occurring. The first, in my career at least, was the discovery of the accelerated expansion of the universe in 1997. And then now, in the last year, there's evidence that the expansion of the universe is not caused by a cosmological constant. The acceleration is not caused by it, and may diminish and may eventually stop, perhaps. And so the cosmological constant has come under question. So that's a really exciting thing. None of that has to do with the other things that we test about the universe, namely the CMB. You can only have a CMB in a universe that once was hot, dense, and that's the context that we mean by the Big Bang. And you can go even further back that every hydrogen atom in your body and its isotopes were formed only during a very brief period, less than 20 minutes after perhaps the origin of our universe. We can't say what the origin was, but perhaps after the inflationary epoch ended, or perhaps after a previous universe collapsed to form our universe. There are people that seriously study that. But there's no way that you can have consistency with that if you don't have a hot, dense phase of the universe where you effectively had an extremely high energy density, extremely low entropy in the early universe, and then the expansion that comes out of it. You don't need dark energy for any of that. Dark energy only starts to play a role about 4 or 5 billion years after the Big Bang, 4 to 7 billion years after the Big Bang. Dark matter, same, hundreds of thousands of years or to millions of years after the Big Bang. You can get the CMB and dark and the formation of the elements only in the model that has a hot, dense phase, and that's the model we call the Big Bang. So these alternative models are just total nonsense. They don't predict the CMB, they don't predict the formation of the elements, they just pick at where there are uncertainties, disputes, and conflict and tension, but that's part of a healthy field. When everyone believes the same thing, like the Earth is flat, that's kind of the last stage of that before you descend into complete and utter madness.
And what's the strongest evidence for the Big Bang? Is it the expansion of the...
I said there's 3 main pillars of the Big Bang. So there's the formation of the lightest elements in the periodic table. That's called primordial nucleosynthesis.
If there wasn't like a hot moment, then those things would not have formed in the quantities that we see them.
Yeah, the universe was a fusion reactor. Mm-hmm. The universe was a fusion reactor at every point in space and time in the extremely early universe for the first 20 minutes. After the first 20 minutes, almost nothing happened. Nothing happens until the formation of the first atoms. So the relics, I always like to think of cosmology as kind of like archaeology. They're fossils that we can study. When I look at you, I'm not seeing you instantaneously, right? Light travels 1 foot per nanosecond. You're 2 feet away. I see you 2 nanoseconds ago. Okay, not a big deal. We see the sun. The sun could have disappeared right now. We wouldn't know about it for 8.2 minutes, right? Same with the nearest star. Nearest star could have exploded 2 years ago. We won't find out for another 2.3 years. However, if we look back to the very beginning, we have fewer and fewer kinds of artifacts, relics, fossils from that period. But in the case of the Big Bang, there are 2 extremely high precision measurements that we've done. One is the CMB. The CMB is the relic radiation, the oldest light in the universe, the oldest fossils in the form of light. What did it come from? The fusion of a proton with an electron. We don't normally call it that, but that's what it is. Binding, or it's another way to say fusion. The equations that govern that tell us that process could not have occurred before the universe had cooled off to below the ionization temperature of hydrogen, more or less. There's some corrections, but so too, the hydrogen and helium in this water and its isotopes, deuterium, and I have heavy water in my lab. I'll show it to you guys. Heavy water, the isotopes of hydrogen, they cannot form. There, it's a fusion process too. Deuterium is the simplest of all nuclei. It was discovered by Harold Urey, who was a professor here. That's a fusion of a neutron with a proton. That cannot happen before the universe is cooled below about 1 billion Kelvin. Okay? That took a few seconds after the Big Bang, and it lasts until there are no more neutrons. Neutrons are unstable; they radioactively decay and beta decay unless they're combined with a proton. We don't know why that's true, but it is true. They'll decay after 880 seconds, and so if you don't make anything that needs neutrons, namely every other element on the periodic table has a neutron in, except for hydrogen, the isotope that we call protium. Everything else has a neutron. So all the neutrons that were produced in the Big Bang are bound up into the periodic table or bound up into things that were made in the Big Bang itself. That's a fossil. So that means you go down to the ocean, you scoop up some water, you say how much deuterium is in there. That will tell you exactly what the ratio was like, because you don't make deuterium anywhere else except for the Big Bang. So you often hear, oh, we're star stuff. Carl Sagan, we're star stuff. We're made of star. No, we're mostly made of hydrogen, and all the hydrogen was made during the Big Bang. So that's what we should think about. So it's the formation of the CMB, and it's the expansion of galaxies in the universe. Those three things point to a earlier, denser, hotter, a higher entropy state, at least in a higher energy state in the early universe. How that started is an open question. That's what we're trying to study.